Now let us try to discuss these problems. I take first problem number 10 and then we will go in for 9. Now in the previous classes we have seen the optical isomers are denoted by small d and small l, dextro and levo, or plus within brackets to denote dextro isomer, minus within brackets denoting levo isomer. Just like our RS notation, we also have capital D, capital L notation. Now first point you should remember is capital D and capital L are different from small d and small l. Please remember again, I want to mention capital D is not equivalent to small d and capital L not equivalent to small l. Capital D and capital L are with respect to configuration. Capital D and capital L are with respect to configuration, whereas small d and small l, dextro and levo, are with respect to the specific rotation. Either the plane polarized light is rotated to the right or left. So capital D and capital L, which is the old notation, is for the relative configuration, I can say. For relative configuration, whether it is capital D or capital L, we should have a reference substance. So with this reference substance, you compare the configuration of the given substance and see in what way in these two compounds, reference compound and the compound under question, the groups or atoms are arranged, or whether you are going to have a similarity between the configuration of the given substance and the reference substance. And for this reference substance, it is this compound which is chosen as the reference. This is glyceraldehyde. Glyceraldehyde. Now, in this glyceraldehyde, you can notice, consider this structure. OH lies on the right hand side, H on the left hand side. Now, any optically active molecule having this arrangement around the asymmetric carbon atom, namely OH lying on the right hand side and H lying on the left hand side, this is given the notation capital D. That is, this belongs to capital D series. This is the configuration of glyceraldehyde in which OH lies here and hydrogen lies on the left hand side. So any compound which has a configurational relationship in such a fashion that in that compound OH lies on the right hand side and H on the left hand side, just as in the case of glyceraldehyde, they belong to capital D series, or in other words, this structure number 1 is D-glyceraldehyde. Now look at this structure number 2. It is obvious. Structure number 2 is the enantiomer of structure number 1, mirror image relationship. So if you have the mirror image relationship, and if this is the capital D configuration, naturally, since there is a mirror image relationship, this glyceraldehyde in which hydrogen lies on the right hand side and OH on the left hand side, this belongs to capital L series. So H on the left hand side, OH on the right hand side. If you find this configurational arrangement, then that molecule belongs to capital D series, whereas H and OH exchange their positions. This is 2 is the enantiomer or mirror image relationship exists between 1 and 2. Then 2 belongs to L series, in which hydrogen lies on the right hand side and OH lying on the left hand side. So if a molecule is given and this H and OH arrangement is like that in compound 1, D-glyceraldehyde, then that molecule in which the same configurational pattern is followed, it belongs to capital D series, and the mirror image of this will have the L configuration, H and OH exchanging their positions as in 2. So instead of small d and small l, dextro and levo, based on the configuration, we can assign notations as capital D and capital L. Again, I want to mention, please remember, capital D and capital L are not the same as small d and small l. Now, come to question number 9. Earlier, we have seen in the previous examples RS notation. This RS notation can be extended to compounds containing more than one chiral center or asymmetric carbon atom. Now, this is carbon number 1, this is carbon number 2, which is asymmetric, carbon number 3 is also asymmetric. Now, we have followed the sequence rule given by Kahn, Pralog, in gold. The same we can follow. First we choose asymmetric carbon atom 2, and when you consider this 2, all these will be considered as a substituent X. Now this molecule becomes like this, that is CH3 H, Br, and all these, this group satisfies the fourth valency, I put X. Now, here hydrogen is on the left hand side. In order to bring it downwards, keep CH3 intact and rotate this remaining portion of the molecule in the anti-clockwise direction. So this will become H coming downwards, X going here, and bromine coming over here. As we have already seen, this is the lowest priority. First priority for bromine. Now CH3 here, compare this with X. Carbon, here also carbon. So go in for second atom. Here the second atoms are 3 hydrogens, but here second atoms are 1 chlorine, 1 hydrogen and 1 carbon. So this is a given the second priority, and this is a third. You forget about this. 1, 2, 3. It will be in the anti-clockwise direction. So as far as carbon 2 is concerned, we say it is 2s. Similarly, consider carbon number 3, H, Cl, CH3, HBrCH3. Now, when you consider the third carbon atom, this is X. Again, since hydrogen is on the left, anticlockwise, H, CH3 will move over here and Cl here. You keep this X fixed. Again, lowest priority. This is 1. Again, of these two, this is given the second priority, 3. Yes, chlorine first, CH3. So, moving in this direction. So, you can notice RS notation can be followed. I think what we have done is correct. So, 4, chlorine 1, and this is given 2, 3. So, clockwise R. So, more than one asymmetric carbon atom you can assign R S notation. We follow?